Right, so we're looking at the refraction of light through a perspex block. The equipment that we've got set up, so our apparatus is a power pack. That's set to 12 volts going to a ray box. The ray box has got a slit, so this allows a narrow beam of light to come through. These ray boxes get very hot. So between each experiment, I was turning off my ray box to make sure that the bulb isn't overheating and causing any risk in terms of me getting burnt. So the hazard is the heat from the bulb. The risk is getting burnt, and we reduce that risk by making sure that it's turned off between each experiment. Now, the aim of this practical is to look at the relationship between the angle going into the perspex block, which is known as the angle of incidence, and compare that to the angle of refraction, so how the bending of light, how much the light is bent. Then we'll compare it of going from the perspex back out into the air. So first thing I need to do is draw around my perspex block. I'm now going to position my ray box so that it's going to come straight out, i.e. no refraction will seemingly have taken place. Although, in actual fact, the speed of light here in the perspex box will be slower than in the air here. So this is now perpendicular to my perspex block. I'm going to draw two crosses and two crosses here. This is so I can move my ray box away and position it back as I need it. Now drawing this line, I'm going to label this line my normal. The normal is the position at which light will travel straight through my perspex block. Normal's always 90 degrees with a flat-edged interchange between one density and another density. Every angle I measure is in relation to this normal. Using a protractor, I'm going to set up my incidence rays before I've even put the ray box back. I'm going to look at 10 degrees, 20 degrees, 30 degrees, 40 degrees, etc. I'll draw each one of these. And I'm going to label each angle there. Also, as this is light, I'm going to show that light is travelling in a straight line, and I'm showing the direction that the light is travelling. I can see my light wave coming out. I'm going to put two crosses, and I'm doing it as crosses to find the middle part of the wave. This will give me a more accurate measurement. I'll have a greater degree of precision with this. And I've done that for my 10 degree. Repeat for my 20. Now, one thing to observe here is at this point, I'm clearly noticing I'm getting some light reflected. So I'm going to put that on as well now. And because I can see it here at my 60 degrees, I'm going to test to see if I can see it at 50. So I'm just going to go back. So this is me making an improvement to my investigation. And yes, I can see it coming back. So a reflection here. But you should be able to notice that is a dimmer light. So less light is being reflected at this angle than at 60. This will help me draw my conclusions later on. Okay, so I've finished measuring all of my angles. I've also noted down that I've got increasing brightness with these reflected rays, and I've got decreasing brightness with the refracted rays. I'm going to transfer this onto a table of results now, because this is all a bit too cluttered right now for my liking. So what I can see here is that air to perspex, my angle of incidence is greater than my angle of refraction. Conversely, perspex to air, my angle of incidence is less than my angle of refraction. And I can take this a bit further. I could say that my angle of incidence 1 is actually equal to my refractive rate 2. And refracted 1 is equal to incidence 2. Now, from this I can conclude, as the light wave enters the perspex block, it's actually slowing down. This is because this first bit, the wavefront, hits the block and then that slows down. What that causes, because this second bit is still going in the speed of light in air, that's going faster this side of the wavefront to this side. So it's going to make it turn. And when it comes out, the other way is going to happen. This side's now going to speed up, whereas this side is still at the same slow speed within the perspex, so it's going to twist back on itself. So that's my conclusion from this. In terms of evaluating the experiment, what I'm looking for now is any anomalies. And I can see here that my incidence 1 and refracted 2, well, they're equal. But on this one here, I can see I have an anomaly there. This one does not fitting in the pattern. So what this could be down to me not positioning the ray box quite correctly with my perspex block. And that's probably the most likely cause of any error of this sort of experiment. It's down to human error on this account.